again, and we are going live today. On the topic for the night is density and upthrust. So we want to quickly look at them and see how it will go. Density and upthrust. Now, we will not waste time. Anywhere we stop, this is part 1. We continue from there. It's just 45-minute video. Then we'll give you time to ask questions. Though today we are dealing with analysis, we are not going to talk about calculation. And we'll ensure that we make sure that everybody comprehends what we are doing. Now, first thing is that we want to look at definition of density. What is the definition of density? How do we define density? Density is defined as the mass per unit what? Volume. Is what? Mass per unit what? Volume. Now, simply, I just give you a simple word definition. Now, some texts will tell you is defined as the quantity of matter in a body for a unit volume. What they are saying is that mass is the quantity of matter contained in a body. Then they will not say is defined as the quantity of matter contained in a body per unit what? Volume. Is correct. Now, there are two statements we have to underline here. We underline mass, then we underline volume. There are two quantities that are being mentioned in trying to what? Define density. Number 1 is mass. Now, what is mass? Mass is what? Is a quantity of matter contained in a body. Contained in a body. Let me increase it right up, please, so that people are. Is the what? The quantity. The quantity of matter contained in a body. So that is the first thing we must know about what? Mass. Number 2 is that mass is what? Is a fundamental quantity. With what? From fundamental quantity with a unit, SI unit of what? Kilogram. Now, another thing again you must know is that mass is measured using a what? A beam balance. Beam balance, or what we call the chemical balance. Chemical balance. Also, we can also use what? Lever balance. And that balance operates on the principle of what? Of moment. It can also be known that mass, after measuring it, it is a scalar quantity. It has only magnitude, but no direction. It has only what? Magnitude, but what? No direction. Take note of that. That one is what? What is a scalar quantity? A scalar quantity is a quantity that has magnitude, but no direction. So that is what we call mass. And don't forget, I've told you mass is measured in what? In kilogram. What about volume? Volume is a what? Is a 3-dimensional space. 3-dimensional what? Space. Is a 3-dimensional space that is what? Measured in form of what? Length, breadth, and width. Or length, breadth, and height, as the case may be. So it can also be measured in form of what? Radius. So is what? Is three-dimensional what? Space. That means that what we are trying to say that volume has to do with what? A solid shape. A solid shape. Don't forget, once you are talking about a three-dimensional space, we are talking about a solid shape. You are not talking about liquid. You cannot talk about rectangle. So rather you talk about the rectangular block. Rather you talk about a square block. You talk about a cone, talk about a cylinder, and talk about every other thing. Now, what can we now say that volume? Can we now say that volume is a scalar quantity? It has magnitude also, but no direction. In other words, we can now also say that since it has what? Magnitude but no direction, and it is what? It is a derived what? Quantity. Nobody is a derived quantity. Measured in what? Volume is a derived quantity measured in meter cube. We can also measure in centimeter. Don't forget, 1 centimeter cube is equivalent to 10 raised to the power minus 6 meter cube. Very, very important to know that. Why? Because 1 C is equivalent to 10 raised to the power minus 2. So centimeter cube is written as 1 C cube meter cube. So centi cube, 10 raised to the power minus 2 all cube, all raised by 3 will give us what? 10 raised to the power minus 6. So in that case, when we are talking about what? That a centimeter can be converted to meter cube, we are talking about what? A conversion that involves volume. Now, as you are saying, let's also talk about volume in its measurement. Don't forget, I talked about how to measure mass. How can we measure volume? How can a volume be measured? Now, we can have what they call a regular what? Shape. That means to calculate what? Volume of a regular what? Regular solid. Now, if you have a regular, to calculate the what? Volume of a regular solid, we are talking about how to find what? Volume of a cylinder. Of a cylinder. Now, what is volume of a cylinder? Class, volume of a cylinder is what? By R square H. So if you are given a cylindrical shape, you are asked to calculate the volume. You just use pi R square, where R is what? Radius, and H is height. Pi is 22 over what? 7. What about volume of a cylinder? Volume of a cylinder, we are talking about what? We are talking about volume. Let's also about volume of a cone. It's 1 over 3. Volume of a cone is 1 over 3 by R square what? H. Now, don't forget, what about volume of a rectangular block? We are going to need all these things of a rectangular block. Volume of a rectangular block is equal to what? Length times breadth times what? Height. We can call it a rectangular sheet or rectangular lamina. So we can what? We can have what? Volume of a square. I will stop here because of time. Volume of a what? Of a cube, rather. I want to say square block. So this one now is what? L cube. The volume of a cube is what? L what? Cube. Because all sides are equal. It's formed by a square. We are done with that one now. Now, what about how? So that means to measure the volume of the what? Of a regular shape. Because the shape is already regular. You can just take the measurement, direct measurement of the shape. You measure it. What about if you want to measure the volume of an irregular shape? Because we need to know all the characteristics that defines density. Now, the volume of an irregular what? Solid. Now, to measure the volume of an irregular solid, simply take a what? A measuring cylinder. When you take that, that is what? Fully calibrated. Now, place a water there. Let's say the level of water is here. This is a rough sketch. Now, let's say we drop a what? A solid inside. This is a solid drop, irregular solid drop inside. What do you notice? Initially, it was what? Probably, let's say the initial level is here. Let's call it V1. As you drop it inside, it rises to what? The level of water inside rises to this point. Let's call it V2. Now, what do we say to calculate the what? The volume of what? Of irregular shape or solid. To calculate the what? The volume of irregular shape or solid. Let me increase right up. To calculate what? The volume of what? Irregular what? Solid. What you just need to do is to what? To now say V2 minus V1. So that is to say, because there is a rising in the measuring cylinder. So measuring cylinder can be used in conclusion. Notes that what? Measuring cylinder can be used to measure what? The volume of what? An irregular what? Solid. So it can be used to measure the volume of an irregular what? Solid. Now, the last one, which is chemistry students should know that. What about if you want to measure a fixed predetermined volume? I will not write this one out because more or less like many of us, I'm talking to science students, so you must have gone to lab and you have seen all this thing I'm talking about. You know what they call pipette and you know what they call burette. Burette is used to measure what? Fixed predetermined volume, like what? The acid, while pipette is what? Used to what? Measure base. So when you suck with your pipette, you measure a volume. Let's say you want to measure 25 centimeter volume given to you. Then you can suck with your what? Inside a what? A conical flask or a beaker. You put the base inside, then you suck to that level. Then you what? You release it on the what? You run it off on a what? On a beaker. Then that one you don't need to measure it again because you have already done the volume measurement with your pipette. Now that can be done. So to measure the volume of a predetermined volume or fixed predetermined volume, to measure what? The volume of a fixed predetermined volume. What have been given to you, want to find the volume directly, you can use what? Burette or what? You can use what? Pipette. You can do that in the lab. Now, we have talked about all the measurement we can achieve through what? How to measure volume or different ways by which volume can be measured. But let us now go up. I define density as that which has mass is as defined as what? Mass per unit volume. That means density is defined as mass per unit volume. Why I'm repeating it because I want you to understand that word mass, which I've explained, and volume. Now let us now write mathematically. Let us write it mathematically. Let's write mathematically. What is what? The formula stated. The mathematical rating. Please, anywhere we stop, we continue because we don't want the class to be longer anymore so that we can always have a live and answer questions because sometimes time doesn't permit us to answer questions. Now, density is equal to mass over volume mathematically. That is to say, Don't forget, this is a scalar, this is a scalar. That means density is a scalar quantity. Density is a scalar quantity. That is it. Which has magnitude and direction. Density, it has a unit of, don't forget, mass is measured in kilogram, volume in meter cube. So therefore, we would have it as kilogram per meter cube. Now this is standard unit, but we can have other unit like gram per what? Per centimeter cube. Gram per centimeter cube. So that is another unit for what? For density. Now the next thing you must know about density is that density is a derived what? Unit, or a derived what? Quantity, rather. Is a derived what? Quantity. And lastly, I will talk about the measurement. Don't forget, I know some of you are expecting me to measure the what? To use what? To mention the instrument that we use to measure density. Well, I'm going to mention that because that one also is a principle. There's a principle backing it up. And if I mention it, I can just only tell you that what? Density can be measured with an instrument called what? What? Hydrometer. Hydrometer is different from what? Hydrometer is different from hygrometer. Hygrometer to measure what? Relative humidity. Hydrometer, hydro. Sometimes in measuring the what? That of milk, we call it lactometer. We call it like lactometer. So that is just that. Then take note of that. Now, we are going to talk about this one in general, but we have what we call measurement of density of gas, which we call what? Aerometer. Aerometer. Aerometer is measurement of what? Density of gases or air. So if you want to measure the density of air or density of gases, you use what? Aerometer. We have what they call areometer. Areometer is a what? Is an instrument used to measure what? Density of what? Liquid. You can use what? Density of what? Liquids. So that is just that. Now, let us go further. Now, don't forget, density can also be called what? The specific mass. Another name for what? For density is what we call the specific mass. We have what they call specific gravity. That one is called what? Is that of the language for what? Relative density. Another name for what? Specific what? Mass is density, but specific gravity is relative density. So take note of that. I said that what? The name, another name for what? For density is what we call the what? The specific mass. Then we have what they call specific gravity. That one is called with the one we relate as what? Relative what? Density. And I also what? I've been able to confirm to you that you can convert what? 1 gram per centimeter can be converted to what? Kilogram per meter. How? Now, if you convert gram to what? To kilogram, that is to what? You divide by what? 1,000 to convert gram to what? To kilogram. What I mean by that, to convert kilogram to gram, you multiply by 1,000. To convert kilogram to gram, you multiply by, for example, if I give you 2 kilograms, to convert to gram is what? Is same as 2,000 grams. 2,000 grams is same as kilogram. To convert kilogram to what? To gram is 2,000 multiplied by 1,000. But what about if I want to convert 2,000 grams to kilogram? Just simply what? Divide by 1,000. You are going to have your what? Back your kilogram. Similarly, you can also say to convert from where? From gram what? Don't forget, to convert from centimeter per centimeter cube. Let me give you an instance so that you can understand what I'm saying. I don't want to be too complex in my tonight explanation. So when we say 1 centimeter cube, I told you before, it's equivalent to 10 raised by what? Minus 6 meter cube. Now look at the board. Now if I have it as what? 1 gram, to convert 1 gram to what? To kilogram is just like what? Divided by 1,000, meaning that multiply by what? To convert gram to kilogram. Multiply by what? 10 raised by minus 3. You convert to kilogram. So that is to say, to convert kilogram to gram is what? Multiply by 1,000. Please take note of that. To convert kilogram to gram, multiply by 1,000. But to convert gram to kilogram, you divide by 1,000. Divided by 1,000, if you say 1 over 1,000, in indices, well, what you learn in SS1, first week after break, some of you have not resumed, you are still collecting uniform. You were taught by Uncle John in your school. I don't know who teach you. That what? 1 over 1,000 is what? 10 raised by what? Minus 3. So that's what I've done. So 1 gram, you want to convert to kilogram is what? 10 raised by what? Minus 3 kilogram. And if you combine these two, you end up, without much word explanation, converting 1 gram to what? Per centimeter cube. To what? To kilogram per meter cube is just simply by what? Multiply by 1,000. Please take note of that. Because if you now say gram, to convert gram to kilogram is what? Divide by 1,000. Then this one is in kilogram. To convert 1 gram to kilogram, divide by 1,000. And to convert centimeter cube, 1 centimeter cube to meter cube is also divided by what? 1 million. If you divide by 1 million, it's the same thing as what? Multiplying by 10 raised by minus 6. So somebody else has said, but you said you should multiply by what? 10 raised by minus 3 now. You can still do it. Look at it. Then to convert centimeter to meter cube, you what? Multiply by what? By 10 raised by minus 6 meter cube. If you do the indices that is involved here, you are going to have this as what? This is what we are going to have as a result. So now you can convert gram to what? To kilogram by multiply by 1,000. And you can what? Because if you work these indices out, this one will go up as plus 6. Minus 3 plus 6 is which was what? 10 raised by 3, which is 1,000. Note, for you to convert kilogram what? Per meter cube to gram per centimeter cube, you what? Divide by 1,000. Opposite is the case. When you are converting like this, you divide by 1,000. For kilogram per meter cube to what? To what? To gram per centimeter, you divide by 1,000. But if you are converting gram per centimeter to kilogram per meter, you multiply by 1,000. To convert centimeter cube to meter cube, you multiply by what? 10 raised by minus 6. Or you divide by 1 million. To convert what? 1 gram to kilogram, you what? You multiply by 10 raised by minus 3. Very, very important. 10 raised by what? Minus 3. So we are able to what? Understand density principles and the mathematicality. So that means mass over volume is equal to what? Density. Now listen to me carefully. Carefully. Listen to me. Now we want to enter the what application now. Application. Now, if density class equal to mass over volume class, let's say mass is constant. In the question now, mass is what? Kept constant. What do we have? Mass will now be equal to dV. In that case, we are going to have what? D1 V1 equal to D2 V2. That means in the case where you are giving density of one substance, you are having two substances. One is giving density and the volume. You are giving what volume of the other one, but not giving density. You can use this formula to solve. Take note of that. So if you are giving what density of one substance, let's say a liquid now, liquid 1, you are giving the volume of liquid 1, you are giving the volume of liquid 2, and you have to find the density of liquid 2. where the mass of the two liquids are what kept constant, then in that case you what use the formula. Similarly, if what the volume is what kept constant, if I keep the volume constant, if you want to make volume drop of a formula here, volume equal to what? Bring this one here, bring this one here. I want to have what? M over density. Mass over density. So if the volume is constant, we are now going to what? Add 1 M1 over D1 equal to M2 over D2. Let me keep you what? Engaged as you are watching the video. Now, I'm going to be giving you this one. What is the instrument anemometer used for? What is anemometer used for? You can type it on the comment section as you are listening. Anemometer is used for dash and dash. It's used to two things you are going to give me about the uses of anemometer. It's an instrument. What is that instrument used for? You understand? Because some of you, if you are not engaging you, sometimes, so this time around, I'll be engaging you as you are watching the video so that we can keep our mind in place. Now, as you are saying, the volume of the is kept constant of the substance. They will use the mass 1, D1, mass 2, density 2. Most of the time, this one is likely to be a solid substance. This one is likely to be what? Liquid or fluids. Because most of the time, when you are dealing with volume and density, you talk more about fluids. When you talk about fluids, we are talking about liquid or gas, or liquid and gas, as the case may be. So fluid is not involving solid. So take note of that. It's not involving solid. So take note of that. That one is gone. Now, how do we determine, according to scheme of work now, determination? This is the next thing, of density. Determination of what? Density of what? Of, let's say, of solid first. Now, for us to determine what? Density of solid now, there are methods we are going to use to do that. And those are the methods we want to focus on now. Now, don't forget, there's what we call relative density bottle, or what we call the specific gravity bottle. It can also be used to determine the density of solid. Yes. Now, but we are going to get there. Also, we call it what? Relative density bottle can be called the pycnometer. Many of you have heard of that name. Well, okay, if you have not heard of it, you can take it down. Pycnometer. Pycnometer is also known as what? Relative density bottle. You understand me? Which is a bottle that what? Specially used to determine whether density of solid or what? Density of liquid. So that is just that. Now, listen carefully. Now, let's go on. How do we determine density of what? Let us what? Calculate the density. Determine density of what? Of a regular shape. I want to take it one by one. The first you want to. How do we determine the density of a regular shape? How do we determine the density of a regular shape? Now, first, we have to know that we are dealing with a regular shape. And if you are dealing with a regular shape, I've told you how to find the volume of a regular shape. So what you are going to do is to what? First of all, to get the volume of the regular shape, I've told you, you must know the shape. So let me give you a table. The density, let me give you a table. Density. Let's talk about the what? The mass and the what? The volume. I will need to calculate the density of what? Of a regular shape. I will need the mass and the what? And the volume. Now, if you take, for example, let's take a cylinder, for example. Let's say the shape is cylinder. Let's take a cylindrical shape. want to determine density of the what? Of a cylindrical shape. We assume the shape is what? Cylindrical. Now, what we are going to do first is to weigh the mass of the what? Solid cylinder. Is to weigh the mass of the what? Solid cylinder in a chemical balance. So we record it as M. Once you weigh it, the next thing you to do is to calculate the dimension of the what? The cylinder, solid cylinder. And to do that, you will need the radius and the height to do that, and that will be your volume. So how do you now calculate the density? Density will now be what? M over what? Pi r squared ish. I'll do one more, then I will leave others for you. Let's take a rectangular shape. I cannot take everything. That's why we are there, to complement this class. Now, a rectangular shape or a rectangular block rather is what? Because block is a solid, it must be a solid. So a block, a rectangular shape can be a plane shape. But when we talk about a rectangular block, we are talking about three-dimensional shape or a rectangular sheet as the case may be. Sometimes we use a rectangular lamella. So now, when we talk about a rectangular block, this cylindrical block, a rectangular block. Now, for this rectangular block, we are going to weigh the rectangular block as what? We call it M. And when you weigh them, don't forget the instrument you use to what? To do that. We call it M. To measure mass, I told you before in the beginning, we use beam balance. Then, what is the volume? I've also talked about volume for you, so I do not waste time there. Then, to calculate the density of what? The shape will now be M over what? L times B times H. So what you are going to do for me now is to do what? Density of what? Cone. Density of a cube. Density of a what? Of a cone. You can what? And density of a sphere. You can balance that one, leave a space for that, and do that by yourself. So that is it. So you need to know the area of a sphere. If you don't know it, check the what? The beginning when we work later on, where we talk about what? Different area of different shapes. So you see for the volume of different shapes, then you work from there, you can get what? The density, and then get the volume and mass accordingly. The next thing to do is to find the density of an what? Irregular shape. The next step is what? The next density of an irregular shape. I don't want the class to be irregular shape. I don't want the class to be arranged anyhow. So we must go do things accordingly. Now, what is the density of an irregular shape? I've told you how to find the volume of an irregular shape by using that experiment I told you. Immerse the irregular shape into a measuring cylinder with containing water. And then note the initial volume of the cylinder before immersing the irregular shape inside. There will be a rise. There will be a rise in the level of the water, which I've explained for. Let's say the initial volume is V1, and let's say the final volume after rising, after immersing inside, you will displace its own volume. So let's say the volume that you displace, it gets to rise to V2. That means the volume of the irregular body will not be what? V2 minus what? V1. You get that one first. Then when you have done that, you weigh the mass of the irregular shape and call it M. The mass, you call it M. The mass of the of irregular shape. You call it what? M. Now, don't forget I've done this one for that. I don't want to waste time because we don't have enough time. Then what will now be the density? The density will now be equal to what? The mass of the irregular shape, irregular solid, divided by what? V2 minus V1. So that is how to find the density of an irregular shape. Please take note of that. What about what? The density of a soil or a sand. You want to look at density of a Of a soil or a sand. Now, how do we calculate the density of a soil or a sand? That means density of a soil or a sand particles. How do we look at the density of the what? Of a soil or of a sand? Now, the formula I will give to you will help you to what? To determine. It's an experiment, which is mass of the soil minus what? Mass of the what? The empty what? This one is mass of soil plus empty what? Empty what? Box or bottle or cone, anything, over what? We now have what? Volume of the what? Of the filled what? Container. That means using what? Soil. Now, let me explain it so that you can understand. The first thing you do is that you must have a rectangular box. It might be a wooden box. It might be just be a container. And that container, let it be able to work. Not the one that it will attract the sand. Ensure that the container is dry, that it will not attract some of the sand when you are doing your measurement. Now, measure the empty what? Rectangular wooden box. After you measure it, you call it what? What? Empty box. Which is what? You can call it M naught. To measure the what? The mass of the what? Empty rectangular box. Then what you are going to do is to what? Is to now fill the rectangular wooden box with a soil. This is a rectangular what? Box. Please permit my diagram. Let's just take it like this. Now, this is a rectangular wooden box that you weigh it, you call it M naught. Then after you weigh it, you now what? Fill it with what? You fill everything with sand. Everything is filled with sand to the brim. Fill the what? The rectangular wooden box with sand. And when you fill it with sand, you now call it what? M what? Of the what? Soil plus what? Plus empty box. Don't forget that what? When you fill it with sand, you are having two masses. So the mass of the box plus mass of the empty what? Of the soil. You are having mass of the empty box plus mass of the what? The soil. Make it two masses. Now, so mass of what? Of soil or sand plus mass of the what? Of the box. Call it what? M what? 2. Now, when you do that, let me call this one M naught. Now, when you do that, that is when it is empty, or you call it M naught. Now, when you do that, now because the sand filled the what? The rectangular box to the brim, then how do you calculate the volume? The volume of the soil will be equal to the volume of the rectangular box. You know why? Because it's filled to the what? To the brim. You cannot just take the soil and calculate the volume. No, it's not possible. So you calculate the volume of the container, because the container will give you the accuracy of the volume. So that will now give us what? Take the what? Let's say this one is volume of the what? Of the soil. And how do you calculate the volume of the soil? How do you calculate it? Please. You want to calculate the volume of the soil. The volume of the soil will be equal to length times breadth. Volume of the soil will now be equal to what? Length times breadth times height. Why is it like that? Because the soil is filling the box to the brim. So the shape of the rectangular box is equal to the what? The volume of the what? Of the soil. So now, what is now the density? Finally, you can now say the mass 2 minus mass what? 0 divided by what? Length times breadth times height. Now, what is he saying? This is a mass of the empty box plus the soil minus mass of the empty what? box will now give you what? Mass of soil over the volume. Because if you subtract what? Mass of empty box from mass of soil plus what? The box, you have mass of the soil. So mass of the soil over the volume of the container, which is the equivalent to volume of the soil, is equal to what? Density of the soil. So you have calculated the density of the soil. The next one is what? How we can what? Calculate using what? Relative density bottle. That means how to determine the density of a particular what? Body. Now let's see the next one. I will stop after this last one so that we can move to the next stage, which is the last part of this truth, so that we can have time for what? For the question. Now, what we want to do now is what? We have looked at what? Density of the regular shape. We have looked at density of an irregular shape. And we have also looked at what? Density of soil. Alternatively, somebody can say, oh, Mr. Halide, what if I have a soil? I measure the mass of the soil and keep it. Because different things, you have different explanation of this. Now, in that call it what? Mass of the soil. You call it mass of the soil. Now, it has a what? It provides a container, let's say a rectangular container, as you say, and fill it with water. It makes sure that the container is dry and fill it with water. Why is it supposed to be dry? It's because when it's not dry, there will be addition of mass. Don't forget, as little as water, that small tiny water has a mass and it has a weight. So you must ensure it's dry. And once it's dry, you want and fill it with water. You now have what? Mass of the box plus what? Water. Let's say water. You can even call it volume. You can get the volume of the body. You can call it volume of box plus volume of what? Water together. Then you get what? That box, fill it with sand. When you fill it with sand and take note of the volume, this is, let's say, V1. Now you have box plus water plus sand. That means pour sand inside that container that already have water. You call it what? V2. Now when you pour sand on it, there will be a rising due to the sand. Now the volume, because you are using measuring cylinder to do this. Okay, you can place it on the wall, on the container, and the measuring cylinder, put water in it. The measuring cylinder, take this as bubbles, then add water to it, then add sand. Then what do you do now? You now get the volume of the sand, which is as a result of soil. Anyone want to use soil or sand? As a result of rising, so which you now get V2 minus V1. Because that, as you put the soil inside that water, it will rise. And that rise now will be leading to what we call V2. That rising of that water will lead to V2. And you now subtract what the initial from final, you get V1, your volume of the soil. Then you can now say density of soil is equal to mass of soil over V2 minus V1. That is another way to get it. Just ensure you study the question very well. It can come in different ways. Don't forget, this topic is more practical. That's why sometimes people find it difficult to solve problem. Now, another thing again is what? Density of mixture. Density of, if you carry two liquid and mix them together, you take a kerosene, you take water and mix them together. How do you determine the density of such a mixture? How do you determine the density of a mixture? Where you have what? The mass of the water given to you. You have mass of kerosene. You have volume of water and volume of kerosene. What do? Density of mixture of liquid. This one now to determine density of liquid now. You have entered liquid now. Is what? Take what? The then mass of what? Of water plus mass of liquid. Mass of water plus mass of liquid. Then divide by what? Volume of water plus what? Volume of what? Liquid. You get your what? Density of mixture. Very easy to get. Now, I haven't gotten that. Sometimes some students will say, oh, Mr. Lee, what about if they give us density and volume? You can convert it. Don't forget that mass of water can give us what? Density of water. Let me use this normal symbol I'm using. Density of water times volume of water. Don't forget, I told you that density is equal to what? Mass over volume. So if you make mass subject of formula, what do you have? You have density times volume. So if you believe that similarly, mass of liquid is equal to what? Density of liquid times volume of liquid. So we can now place all this one accordingly into the what equation. The equation becomes density of mixture is equal to what? What? Density of water, volume of water. I've replaced this one plus density of liquid, volume of liquid. Then divide by what? Divide by what? Volume of what? Water plus volume of liquid. This is another formula you should take note of that. Now this is density of mixture. I've given you this one. The last one there, which is not, which this one majorly appear in what? Alloys. When you what? Where alloy is a mixture of what? Of metals to improve the metal. That is chemistry anyway. So that means that we are going to have it what as what? Mass of what? Want to what? Have it in only in terms of mass and density. Mass of water plus density of water divide. Now convert this one to what? To mass and volume and density. Convert each volume to mass and density. Don't forget, volume can give us what? Mass over density. That is what volume can give us. So if volume is what? Look at here now. Bring volume here, bring density here. So what I want to have now, you can say mass of water divided by density of water is equal to what? Volume of water plus what? Mass of liquid over density of liquid. So this one will give us density of mixture. So that is just that. Now, if you know this one now, you can what? Calculate the density of mixture. Density of mixture. Now, I want to know what density of a liquid. How do you find what? The density of a liquid. Now, the formula to use, that is the last thing there about density. That is the last thing there about density, about the determination of density. How to find density of a liquid. We can use what? Relative density bottle, or what we call the what? Specific what? Gravity bottle. To what? To look for density of what? Of mixture. Of liquid. Now, first thing you do is what? This is your what? Relative density bottle. This is sketch anyway. So don't take it personal. This is stopper. Now, if this one is relative density bottle, a sketch of what? Relative density bottle. Now, what you want to do is what? Measure the what? Or weigh the what? The density bottle. Ensure that the what? The what? Weigh the what? Relative what? Density bottle. Or before I can do this one under, let me do it under this way. First of all, let us what? Do it this way. Now, when you have a bottle, empty it. I don't want to talk about relative density bottle now. Just let me talk about the density. And when I get there, I will talk about it more under the relative density. Now, let us weigh the mass. Weigh the mass of the what? Of this bottle. Weigh the mass and call it M naught. Now, when you weigh the mass and call it M naught, or weigh the beaker, let's call it beaker. Let me not call it relative density. Let me call it beaker. Weigh the beaker and call it M naught. Then fill the beaker with what? With kerosene. Let me make it beaker format. This beaker. Let me convert it to beaker. Weigh the beaker, then fill it with what? a liquid called kerosene and weigh it again. So weight of what? Of kerosene and beaker. Then call it what? M1. After doing that, what we want to do is to what? Calculate the volume of the what? Of the container. Probably what? Sometimes we what? We can calculate the what? The volume of the container. We can fill the what? The beaker to the brim. You understand now? You can fill the beaker to the brim with that kerosene to make it easy. Let's say the beaker is a what? A cylindrical what? Shape. Then you can fill it with what? To the brim. After filling it to the brim, you now what? Measure the volume of the what? Of the cylindrical beaker now, or the beaker of the cylinder. You get it per r square h. I've given that one before. Per r square h. Then after getting that, then you can now what? This mass of this one minus this one to get mass of kerosene. Then divide that, because the volume of the kerosene is equal to the volume of the cylinder, because it's filled to the brim. So whatever the beaker contain is what? Because it's a liquid occupies space, and the space of the liquid is can be what? Used to calculate the volume. And if I put the water inside the what? A cup, and I tell you to find the volume of the water, you don't need to begin to pour the water and begin to calculate. It's not easy to calculate, because it's what? In English, they call it an uncountable noun. You cannot begin to count it. So you fill it what inside the container and calculate the volume of the container, thereby arriving at the volume. So when you know your volume, so we now say what? Mass of what? Of kerosene. Kerosene, you get it, divide by what? Volume of kerosene. So you get it like that. Now, to end it, now you know how to find mass of kerosene. I hope you know. Just what? Subtract what? M1 minus what? M1 minus M0 divide by what? The volume. Volume of what? The container here. So that is how you get what? That one. I think that one is clear, and it's clear, and it's clear. Now, what we want to do next is where we are going to end for today is what? Relative density. Relative density. What is relative density? Relative density is a density of a substance, is a ratio of density of the substance to the density of water. Is a ratio of density of what? Of a substance to the what? Density of water. Relative density, RD, is defined as the what? The ratio of what? Density of substance to the what? To the density of water. So that is to say that relative density is defined as the ratio of what? Density of substance to density of water. So relative density now can be taken or can be likened to what? To density of substance over density of what? Of water. We can also define it as mass of what? Of liquid over mass of equal volume of water. You can say mass of any liquid with a particular volume, then over mass of equal volume as the substance, also the liquid, to of water. So that's why we define it as what? We can define it as mass of what? Of a liquid, any volume of liquid, divide by what? Mass of what? Equal volume of liquid. Mass of equal volume of liquid. So now, to get what? To determine the what? The relative density of liquid. Most of the time we use what we call density bottle. We use what? Relative density bottle, which we call what? The specific what? Gravity bottle. We can also call it what? A picometer. What? No meter. That is, I've said about it for picometer. We can use micrometer to measure what? Volume of the what? Density of volume of density of solid. We can also use it to what? Measure relative density of what? Of liquid. If you don't forget, hydrometer. Let me make this one clear, because some of you now will mix it up. Hydrometer can be used to measure density, and it can also be used to measure relative density. Let me tell you, because some of you might be having question on that. Okay, what about relative density? Yes. Do you know if you have density or if you have relative density, you can calculate density? It's as simple as that. If you have relative density, you can calculate. What is the relationship between density and relative density? Density times 1 in gram per centimeter cube, or times 1,000 kilogram per meter cube. I mean, if I want to convert relative density to what? To density in gram per centimeter cube, you multiply by 1. Relative density times what? 1,000. To convert specific gravity or relative density into kilogram per meter density, you multiply by 1,000. Sir, please. You did not have a sphere. And a sphere is what? 4/3 pi r square, pi r cube rather. The volume of a sphere is 4/3 pi r cube. 4/3 pi r cube. That is a sphere. Please take note of that. Then this one say, can we say that the density of mixture is the sum of what? Sum of the density of both? No. You cannot say it's there sum of. It's the sum of mass per unit sum of volume. You cannot just add their density together like that. No. If you do that, you are what? Because the two of them did not mix. Don't forget, they add kerosene together with water. Because chemistry students, you can believe that they will have two phases. It will be heterogeneous. It's one will what? Be down, one will be up. So you cannot add their what? Their density together. It's not possible. I think that question will be answered. Another question I will ask you: how can we differentiate density? What we have learned so far. How can we differentiate density from relative density? Don't forget, density has no unit. I mean, relative density has no unit, but density has a unit. Why? Because density is talking about what you are comparing density of other substance with density of water. Density of water is 1,000. Listen to that. Density of water is what? 1,000 gram per what? Kilogram per meter cube. Or we are already asking questions. If you have your question, we are done. Or 1 gram per centimeter cube. Please take note. We are rounding off. So this 1 hour. So please, so that answer your question. The standard what density of water is 1 gram per centimeter cube or 1,000 kilogram per meter cube. That is by standard. So what relative density does is comparing what? The density of other liquids with the what? Density of water. So it's comparing. It's a comparison between what? Quantities of liquids. So that's what relative density does. Why density is already a measured quantity. So density of what? Of something now is a measured quantity. Before you can take the density of a liquid, you have measured it. And most of the times there is an error in the measurement of density, but in the measurement of relative density, there is an accuracy in it. So there is a degree of accuracy in trying to measure relative density than measuring density. That's why most of the times in measuring density, you have to also measure relative density and convert it to density. Because there is what in measuring density direct. That's why you see sometimes they will tell you hydrometer is used to measure relative what? Density. Why? Because they want to, if you can get density to get what? If we can get relative density to get density will not be hard. Just multiply by this thing, you have gotten what? Density. So don't forget this word density word. It has an error. There's an error to it too. Don't forget, density is mass over volume, while relative density is what? Density of substance over density of water. We see our density definition in terms of upthrust. I've not entered that part. When we enter upthrust, like upthrust is the last thing we are going to do with. This is part 1. When we get to what? Part 2, we are going to talk about upthrust and what? The law of flotation. So upthrust and the law of flotation. I think that under upthrust, we are going to talk about what? Relative density again. So there are other formulas that I have not given you under relative density that I have to make you understand what is upthrust first. Don't forget. I've also told you that you can differentiate between the two of them. And why we have to differentiate? Because in the examination condition, they ask you to differentiate between mass and density and relative density. Density as what is measured as mass per unit volume. Relative density is what? Density of substance over what? Over density of liquid. Density can have an error, but relative density have what? A degree of accuracy. Density is measured in kilogram per meter cube. Relative density does not have a unit. What about the similarity? The two of them can be measured with what? Hydrometer. The two of them can also be what? It's a scalar quantity. So I believe what, if you have your question, please quickly direct us, and because we are already rounding up now, we're about to leave the studio. Please ask your questions so that we can answer you. Ask your question. When we get to next class, we are going to talk about how the world, all these things can be measured, how other things that we can use to measure relative density, which I will expatiate in next class. But next class, I have to tell you that when you place a body in water, there is a force that helps to act as to help you reduce the load in water, and that force is what? An upward force. That force is an what? Apparent weight, because it gives the body a different weight in water when you place the body in water. And we are going to look at Archimedes' principle. How can it be used to explain? We are also going to look at what? Flotation. Principle of what? Flotation. We are going to see how submarine can go inside the water and also rise. Don't forget, a submarine can go inside the water and can also rise. This is what? A principle of what? Flotation. When they blast, the ball blast, the ballast, let me call it ballast, the ballast. When they have two ballasts, and when these ballasts are soaked with water, they go deep inside the water, because their density will not be higher than the density of water. And when they now will compress air, when the submarine compress the air, all the water in the two sides of the ballast of the submarine begin to drop. They begin to fall back to the water, and before you know it, the submarine will rise again. So when an American or a soldier or a military soldier trying to attack a particular country, rather they will go with submarine to go inside the water. You will not know they are already coming. Why? Because the ballast on the two sides of the submarine ship, which we take in water. And when they take in enough water, because they have the ability to take in water, they will go down the water deep, and it will not affect anybody, all the soldiers that are inside, all the militaries that are inside. And once they want to come up, they compress the ballast again, and they drop water, and they start rising. And as they rise, they start to float. All this are we're going to look in the next class. Thank you very much. I love you guys, and we have had a wonderful time. And I want to appreciate God. I must do that. Appreciate my wife. Appreciate Mr. Samuel, Engineer Samuel, which is he has been very wonderful at the back room. And also my wife. I've been taking so many questions, and I will continue to appreciate you guys. Most especially, let me also appreciate the viewers. Oh, you guys are wonderful. I don't think Holiday can be encouraged to be here without you guys. Students, I love you, and I remain humble to always deliver what God has been deposited in me. Thank you very much. Those of you that make comments, please share this video. Let other students know about it. We want to have more views to make sure that we bless more lives, because exam is coming. Some of you are writing professional exams to travel. Some of you are writing other exams. Some people that are writing Nigerian exams maybe you are writing other advanced programming and what program or other exam, exam in Europe or America or anywhere. This one can be a foundational background for you to come to lay on with as you go on in maybe in your academics on this particular topic. Thank you very much. God bless you, and I wish you success in life. Thank you.